let us talk about relationship degree. The relationship degree indicates the number of entities or participants associated with the relationship. First, we have unary relationship, wherein the association is maintained within a single entity. Let's take for example this one, employee entity. We all know that managers are also employees. So instead of having a separate table for managers, we can just have a unary relationship with the same table that captures the relationship of employees with their managers. So as you can see in the unary relationship, we have one employee can manage either 0 or many employees. It will be 0 if they are only employee as well, or many if they are also managers. But an employee can only be managed by 0 or 1 manager. So the manager is also optional. Maybe the employee is the owner or he himself is the manager. Next, we have the binary relationship, wherein we have two entities that are associated. Like for example, in the professor and class, we know that professors are teaching 0 or many classes. It is optional because there are certain professors who are only doing research and not teaching classes. For the classes, of course, they need to have one and only one professors. That's why it's mandatory and it is only one. Next is ternary relationship, wherein you have three entities associated, and usually this does not exist and if we are going to implement it as a relational database, but this is on the conceptual level good to know. And we also have the recursive relationship, and the relationship exists within a single entity type. And this is more or less the same as the unary relationship that we tackled in the previous slide. Now, relationship can exist between occurrences of the same entity set. Naturally, such a condition is found within a unary relationship, and it's common in manufacturing industries. One common pitfall, however, when working with unary relationships is to confuse participation with referential integrity. Similar, but because they are both implemented through constraints on the same set of attributes. The following are some examples of the entity relationship representation of the recursive relationships. The first one, if you are going to capture the marriage of employees to other employees. Second one, if you would like to capture the relationship of the managers. And last one, if you would like to have if you like to capture the courses that are generated for multiple courses, so we have a many-to-many relationship to them. Now let us talk about associative or composite entities. They are used to represent a many-to-many relationship between two or more entities. The associative or composite entities has a one-to-many relationship with the parent entities, and they are composed of the primary key attributes of each parent entity. It may also contain additional attributes that play no role in the connective process, just additional data or information. We have already seen an example of associative entity, but this one would be the complete version of that example. You can see that the student and class, they have a many-to-many relationship. A student can take many classes, a class can take in many students, so we have a many-to-many relationship. So we broke down that many-to-many relationship by creating an associative or composite entity called enroll. And as you can see in the enroll, you have one-to-many relationship going from the original entities to the composite entity. And also in the associative entity or composite entity, the primary key that you have are precisely the primary key in your original entities, which are the class code for the class and the student number for the student. As we have said in the previous slide, we can also add additional information that do not have a connection to what we have done. Like for example, since the enrollment would capture the enrollment of students in certain courses, you might also have the enrollment grade in the composite entity. The following are the activities involved in building an entity relationship diagram. First, we create a detailed narrative of the organization's description of operations. Then we identify business rules based on the descriptions. Then identify the main entities and relationships from the business rules. And then develop the initial ERD. identify the attributes and primary keys that adequately describe entities, and then revise and review our ERD.